So we're going to continue looking at some other examples for finding the area under the standard normal distribution curve. So our next example asks us to find the area under the standard normal distribution curve to the left of z is equal to 1.41. So again, let's begin by drawing a picture of our curve. Remember, we put a line down the middle, and that is 0, or our mean. So the first thing that I want to do is I want to mark off the 1.41. So remember that since it's positive, it's going to go somewhere on the right-hand side of the curve. So I'm going to draw a line, and I'm going to call this 1.41. Now, the problem says that we want to find the area to the left of that value. And so I'm going to shade everything to the left of that value. Sometimes students will think that the problem is asking us to shade just this part. Remember that if it had wanted you to shade that part only, it would have been worded, find the area between 0 and 1.41. But since it says to the left, it means everything to the left. So now we're going to go to our table and we're going to look up a value of 1.41. So remember that to find 1.41, we are going to use the first two digits, the 1.4, and then the hundredths place digit across the top, which would be the 1. And we're going to intersect that row and that column, and we'll find that our area is 4207. Now again, it's important to remember that when you use the table to look up an area, you are finding the area between 0 and the number that you looked up. So this 4207 is the area from 0 to the 1.41. So that part of the curve, I'm going to go ahead and write in here 4207. So now I'm left with the question of what is the area of this part? So remember that when we talked about our characteristics of the normal distribution curves, that we said that the entire area under the curve, if everything is shaded, is a total of 1. So what that means is that if you have a curve and everything is shaded underneath, that curve has an area of 1. Now, remember that the line that we draw goes straight down the middle. So it's going to take that curve that has an area of 1 and split it into two pieces of equal value. So if the total area is 1, then the entire left-hand side is a half, and the entire right-hand side is also a half. Okay, think about that. Make sure that that makes sense. We know that the total area of the curve is 1, so the left-hand part is a half and the right-hand part is a half. And coming back to my problem, since I have the entire left-hand side shaded, I know that the area here is going to be 0.5, which is the decimal for a half. Okay, so now the last thing that I need to do is I need to find my total area, which will be the answer to the problem. So I know that part of it is 0.5, part of it is 4207. To find the total area, I'm going to add those two together. So I'm going to say 0.5 plus 4207, and that's going to give me a final answer of 9207 for the total area of my shaded region. Okay, so moving on, we're going to try another example that is similar. This time we want to go to the right of negative 0.82. So we're going to start off the same way. We're going to draw our curve. Put our line down the middle at 0. And then we're going to mark off negative 0.82. So again, a negative value is going to get marked off on the left. And the problem asks us to shade to the right of that value. And again, they're saying to shade everything to the right of that value. So now I'm going to go to my table and I'm going to look up 0.82. So down the left-hand column, I'm going to find the 0.8, which is here. And then across the top, I'm going to mark the hundredths place, which will be here. We're going to intersect that row and that column. And we'll see that our area is going to be 2939. And remember, the most important thing you can remember is that when you look up an area in the table, you are finding the area between 0 and the number that you just looked up. So 2939 is the area from here to here. Now, we have a similar issue that we saw in the last problem. We have the left-hand piece done, but now I need to determine what the right-hand piece is. And I note to myself that the entire right-hand side of the curve is shaded. So if the entire right-hand side is shaded, we know that the area of that right-hand side is 0.5. And then to find my final answer, I would need to do what? Take my two pieces and add them together. That would give me a final answer of 7939 for the total of the shaded region. The last example that we're going to look at in this section asks us to find the area under the standard normal distribution curve between z equals negative 0.73 and z equals 1.14. So again, I'm going to begin by drawing a picture of my curve. I'm going to mark off my two z-scores, noting that I have a negative z-score and a positive z-score. So the negative one will be somewhere on the left, and the positive one will be somewhere on the right. The problem asks me to find the area in between these two values. So we are looking at the area of those two pieces. So again, I'm going to go to my table and I'm going to look up both of these areas. I'm going to start with the positive one, 1.14. So I'm going to find the 1.1 and the hundredth place will be the 4. And I'm going to intersect those two. All right, and so you can see that, and I'm going to have to go to my actual table here. You can see that the area at that intersection point is 3729. And again, remember that when you use the table to look something up, you are finding the area between 0 and the number that you looked up. So this 3729 is the area from 0 to 1.14. Okay, so now let's look up the other one. So the other one is 0.73. So we're going to mark the 0.7 and the 3 and intersect those two. And so that's going to give me 0.2673 for this part. And again, when we look up an area in the table, we're going from 0 to the number that we looked up. Now, how do we find our final answer? We have two shaded portions. In order to get our total, we're going to simply add those two together. So we're going to say 2673 plus 0.3729, and we're going to add those two values together. And so we'll end up with a total area of 0.6402. So now it's your turn. I've given you 3 problems on the screen that I want you to try. You have the answers listed so that you'll know if you get them correct or not. So for each of the 3 problems, draw a curve, shade the appropriate area, look up your area and decide, do you need to add 0.5? Do you need to add the areas together? How do you want to approach finding your final solution? If you work the problems and you don't understand, or you're not getting the correct answer, or you have questions, please let me know by email and I will give you a further explanation.